In this unit, we're going to study how to prove lines are parallel, and this is unit 3.3. If you recall from the last chapter, we learned how to write conditional statements. So if I have P, then I have Q. And P is called hypothesis, Q is the conclusion. Now, the converse of it is if I have Q, then I have P. I simply switch the condition with the hypotheses. So then if you recall from the last unit, we said if two lines are parallel, then I have four pairs of angles. Three pairs are congruent and the last pair is supplementary, right? So in this unit, we simply switch them. If you look down here, now you have corresponding angles converse, which states that if the corresponding angles are congruent, then the lines are parallel. So going back to what we just talked about, that's simply a converse of the statement that we learned in the last unit. Same thing with alternate interior, which states if alternate interior angles are congruent, then the lines are parallel. So now your conclusion is that you're trying to prove lines are parallel. So let's look at some examples here. Corresponding angles converse, and we've got a diagram up on top. Then we're saying let's find a pair of corresponding angles. So I would take angle 1 and angle 5. So the statement should say if angle 1 is congruent to angle 5, then L is parallel to line M. And for the second one, alternate interior angles, we can do 4 and 6 or 3 and 5. So we can say if angle 4 is congruent to angle 6, then these two lines are parallel. L is parallel to M. For alternate exterior angles, we have, I'll do 2 and 8. How's that? If angle 2 is congruent to angle 8, then line L is parallel to line M. And finally, if I find a pair of consecutive angles, let's do angle 4 and 5. You can do angle 3 and 6 as well. So you can say if the angle measure, they have to be a linear pair, right? Angle measure of, I did 3. Then I have to do angle 6. If they add up to 180 degrees, which means they are supplementary to each other, then the two lines they're associated with are parallel. Okay, so in this unit is all about the converse and how we use the converse to prove two lines are parallel. Let's look at this. Here I have this diagram, and I'm asked to determine which lines are parallel by what converse. So I'm given, number 1, I'm given angle 2 and angle 4 are congruent. So let's see if I can make my highlighter here a different color. So I have angle 2. Can I do this? Nope, sorry. Angle 2. Ooh, that was too big. Never mind. So if I have my angle 2 here and angle 4 here, and if these two are congruent, the line they're associated with are C and D. They're both under C and D if I turn my paper to the right, right? Or if I look at it this way, they're both to the right of the parallel lines. Therefore, the parallel lines should be C is parallel to D because they are corresponding angles. Angle 5 and 10. 5 is here, 10 is here. So 5 and 10 are alternate interior angles. So that of line 5 and 10. So if this is of A and B. So A and B are parallel because 5 and 10 are alternating around transversal C. So that's alternating interior angles I should mention all of these are converses. Next, if I do angle 6 plus angle 10, 6 and 10, they are same side interior along C. So therefore, they're proving A and B are congruent. So this is same side interior angles or consecutive angles. Okay, so try to finish another, I'll do two more, 1 and 14. 1 and 14, these are alternate exterior angles, and they're proving A and B are parallel. And finally, 14 plus 15, if you look at it sideways almost, 14 plus 16, they're on the same side of transversal B, so they're proving C and D are parallel because they are same side interior angles. So pause the video, finish the rest of the reasonings and the identification of the converse. And if you have questions, make sure that you ask in class or just find your teachers during off hours. I'm going to do a couple of examples of this as well. So for this one, number 2, I am given 9 and 12. 9 is here. Where's 22, not 12. 22. These are alternate exterior angles along Q and R. So that means Q and R are parallel, right? And then if I look at 8 and 13, they are same side interior or consecutive interior angles of P and Q. So it's the same thing. You need to find out their relationship. 1 and 17. Well, this is a little far away, so see if I can erase everything. If I have 1 here, let's see. If I have 1 here, why are these so big? Let me erase these, see if I can make them smaller. There we go. If I have, see if I can make it smaller. If I have angle 1 here, angle 1 here, and what's the other one? I have angle 17 here. That doesn't help us. Never mind, let me just erase that so that we can see this. I'll just use my pen. Angle 1 is here, angle 7, so much better. Now we can see both of them are affiliated with P and R. So P and R are congruent because both of them are corresponding angles to each other along P and R. Okay, and 16 and 20. 16 is here, 20 is here. So 16 and 20 are alternating interior angles between Q and R. So this is alternating interior angles. Look at 10 and 13. This one, G here. 10 and 13. Notice 10 is affiliated with S, and 13 is associated with T. They're two different groups, so there's not a relationship. Nobody is parallel. You cannot prove anything with that. Okay? Now, here are two proofs. How do we do proofs with these? So 2-column proofs are definitely seeping back, but trust me, this is, as long as you understand the different relationships between the angles, this is a lot easier than what we have seen. So let's look at this one. What's given is 4 and 5 are supplementary. So this we write down here, that's given. We have to prove J and K are parallel. So we're told 4 is here, 5 is here. If they're supplementary, they add up to 180 degrees. That's definition of supplementary angles, right? And therefore, we can draw the conclusion that J and K are parallel by converse make sure that you write out the word converse. Converse of their same side interior angles. Okay? Second one, given 1 and 2 form a linear pair and 1 and 4 supplementary, we have to prove A is parallel to B. So I like to first label out all the ones that's given so that I can get these points first. Now, I'm sorry, I made a mistake there. So the second given is 1 and 4. See how easy it is to make a mistake. Now, if 1 and 2 form a linear pair, they are supplementary. So that's obviously same thing. That's supplement theorem. Right? And then if they're supplementary, they are number 4, 2 and 4 are congruent. So this is congruent. We haven't seen this one for a while. This is congruent supplement theorem. Remember, if angle 1 and angle 2 are supplementary, angle 1 and angle 4 are supplementary, that makes angle 2 and 4 congruent. The relationship is here. It's almost like transitive property. And if 2 and 4 are congruent, they're corresponding angles. And since we're proving lines are parallel, so this is converse of corresponding angles. Okay? Finally, these are just some algebra stuff, but you guys are very good at this. If you first identify the relationship, so in the first one, they're alternate interior, and here's your setup. That should be your setup, and if you do your algebra right, you should have your answer as x equals 16. Let's look at and then we should know that their converse is alternate interior angles converse to prove that A and B are parallel, right? So let's see. Let's do number 4. It's a little bit slightly more tricky. These two angles, what are they called? They are alternate exterior, right? So this angle here at 33 and this angle here. So in order for the two lines that are parallel, these two must be congruent with each other. And so you should have x equals 4. And we said these are alternate exterior angles converse. So it's not hard, this one, but it does reinforce all the relationships that we have been talking about in the first three units. So my mind is already on the quiz. Make sure that you study hard and smart and understand all the relationships, and good luck in your quiz. Bye, guys.